Hi team, my name is Prashant Choudhary and this is my defense video for the AI engineering role. So first I'll go through the architecture and explain how a request flows end to end in my whole system. Then I'll deep dive into some of the non-obvious design choices that I make during this whole project and what were the trade-offs and why I actually implemented them. So first of all, about the architecture, we have an HTTP endpoint, a safety guard that intercepts harmful queries, intent classifier for deciding which agent will work on the query, agent router that has the actual orchestration logic. Then we have the portfolio health agent and other stub agents. So for the request lifecycle, whenever a query is received by our HTTP endpoint by any source, it first of all goes to our safety guard. Safety guard preprocesses a query, normalizes it, and uses a regex based algorithm to classify uh, if the request is harmful or not. So it uses many rule based patterns for classifying a query into different categories, for example, insider trading, market manipulation, money laundering, etc. However, it does not block educational queries like what is insider trading, explain to me insider trading, something like that. So yeah, if a request fails to pass the safety guard, the user will be given an appropriate response why his request could not be passed further. And if it does pass, it goes to the intent classifier. Intent classifier is a single LLM call that returns a structured JSON output. It gives agent it gives the basically the agent that it has decided to route the request to intent. Intent is the reason why this particular request got given to the this particular agent. Then we have entities, and it is basically the input for the next agent. And then we have safety verdict. Safety verdict is basically our last defense against harmful queries. So, for example, if a harmful query passes to the safeguard, it will be caught here by the intent classifier and it can be intercepted at this layer. And after the intent classifier output is given, it goes to the agent router, and and it routes it to our different agents, portfolio health agents or other agents. Only the portfolio health agent has been implemented for now. However, you can give the request to other agents. They will only return the response as this agent has not been implemented yet. So, talking about the portfolio health agent, what it does is basically it compares the user portfolio to the market data and generates a complete report for the user. It highlights different risks and different observation about the user portfolio in that report. One important point is that portfolio health agent does not use any LLM call. This is completely deterministic and completely rule based. This is an intentional design choice that I've made because for this agent you have to work with real world data as well as a lot of numbers, and LMs are not good with working with numbers or real world data. So risk of hallucinations becomes very high here. So instead of that, I have implemented a completely rule based algorithm for that. uh, for the portfolio health agent especially, this agent will be used a lot by the users because they will like to know about how their portfolio is performing a lot of the time. So this agent has to be very very reliable, so we cannot afford hallucinations at this level. So that is why I've implemented it as a completely deterministic agent. So what it does is basically gives various risks about your portfolio, compares it to the benchmarks, compares it to the real world data, how it is performing. It uses Y Finance library to get the real world data, and it shows various observations regarding the user's portfolio. So this is almost it about the architecture. Apart from that, I also have in-session memory, which can easily be uh, migrated to Postgres or Redis based on the requirement. I also have a classifier cache for the LLM generated responses for the intent classifier. Uh, so how the cache works is basically if the user wants to know his portfolio health, and the LLM generates a response, and if after a few turns user again wants to know about his portfolio, then the cached response will be given back to the user. But this cache only lives for 5 turns, because after 5 turns the context of the conversation might change, so that cache might not be useful. So that's why I've implemented only a 5 turn cache. Uh, and uh, now regarding the other design choices that I've made in the whole system, I've already told you about why I used a rule based algorithm in the portfolio health agent and not an LLM call. Apart from that, another design choice that I made was our agent router. Agent router helps us to completely decouple the classification logic from the routing logic, which makes the system a lot more scalable. So if you want to add another agent, you would just add the agent function into uh, the router's registry, and the new agent will become the part of the flow. It reduces friction and makes scaling to more agents, adding new agents a lot more easier. And apart from that, the way I'm getting the market data. So in my current system, only the portfolio health agent uses the market data. So it would make sense to uh, add the market data API to the portfolio health agent. But in the future, there might be other agents that want to use the market data. In that scenario, it will not be a wise decision to implement the market data API in the portfolio health agent itself. That is why I decoupled the market data API from the portfolio health agent and made it in a separate module. So whenever any agent wants to get the market data, they just use the function that calls the market data API, and they will get the data. So I have to implement it only once. In a very similar way, I have decoupled our LLM from our whole from our classifier. So in a way that our whole system becomes provider agnostic. Even if it's a Gemini API you're using an OpenAI model, doesn't matter, because uh, our LLM because our classifier only calls our LLM client, and it passes the request to that particular provider itself. And even in the future, if we want to add another provider, for example, currently I'm using Gemini and OpenAI. Even in later, if I want to use Anthropic, I only need to implement a function here, and it will automatic, and it will won't touch any other code anywhere else. So yeah, these are some of the design decisions that I made during the whole project.